I am the Director of Engineering at Starbucks, and we're working on a project called Unified Commerce Platform. And what this really is for us is the complete reimagining of our entire rewards and mobile order and pay systems. So one thing to know about Starbucks historically, it's not really a technology shop. It's a place where we leveraged a lot of package systems to be able to implement this kind of functionality in the past. And a lot of those systems have scaling limits, and they have a limited capability for us to be able to implement new features. So if you think about this from Starbucks' perspective, if we buy a package from someone, and then we say we want to do something really cool that will enable new ways to engage with our customers. Well, the only way to do that is to tailor these packages, and then all of our competitors get it as well. So it's not exactly the sort of business value we want to unlock for everybody else. So the Unified Commerce Platform is really Starbucks saying we need to be much more of a technology company. And they made some decisions before I showed up, such as we were going to leverage Scala and Akka and Cassandra and Kafka, and really use this reactive stack that you hear so much about these days. And that's actually why they hired me, because I used to work at TypeSafe, Lightbend now, helping people as the head of global consulting and training, helping people adopt this and really helping companies make the transition to these kinds of approaches. The great thing for me is now I get to actually put stuff into production. When you work at a vendor, you don't get to do that so much, or at least you may help somebody do it, but it's not your baby, right? It's not the thing that you help build. And I'm super excited to say that for the very first time, we are in production in Japan with a new system that has added 2 million new rewards customers just in that market. And for me, this is fantastic. And mainly because if you look at the US, which is our largest market, we have roughly 50 million rewards customers, of which I would say roughly 16 million are active, people who are regularly interacting with us on a daily or weekly basis. So a lot of people will create a rewards account, and then they want to get the free birthday coffee or something like that, and then they won't come back. Or maybe we even had somebody who once tried to create roughly 280 different accounts for a free birthday coffee, and at that point, we kind of said, come on, we don't mind that people want to get the free coffee. We give away a fair amount of free coffee, actually, but at the same time, let's be fair to each other, right? And that's actually one of the things I love most about working at Starbucks is it's a company that does care deeply, not just about their customers, but about the world and making a positive impact. So it was really interesting. I was just sitting in David Nolan's talk prior to this, when he was talking about Datomic, and he was talking about how we want to really limit the amount of complexity in our code. And for me, one of the things I really want to make sure we do is not just go out and, whenever you sit there and say, hey, we're going to use Scala, we're going to use Akka, we're going to use all these really fantastic technologies. I want people to use them sanely. I don't want people saying, all right, well, we're going to write all of these incredibly stateful services. They're going to have clustering, and us trying to figure out how we'll deal with whenever a sharded node goes down and how we're going to bring that back up with all the data that was on the node that went down and all that kind of craziness. We aren't high-frequency trading. When you look at Starbucks, it's a company that has 91 million transactions a week in North America. And, I mean, that's sizable scale. It's not high-frequency trading. It's not dealing with the financial markets or anything like that. We don't have to write something that has to be the most complex approach to leverage the most highly optimized solution. So I prefer for my team to think about how we can leverage tools to deal with tough problems rather than writing that in code. That way we keep things as simple as possible, make the system more maintainable, and whenever it comes to dealing with consensus and really difficult problems, we leverage tools that have done it really well over time. So I looked at Cassandra. It was actually the database that we were given. At Starbucks, when we're building this platform, we decided that we were going to do something that's also very difficult. We were going to build a PaaS over AWS of our own. And the PaaS is a beautiful thing. There's another team dedicated to this, and what they do is, infrastructure as code so that we can rebuild an environment or deploy into a new market really quickly, but also security by design. And security by design means that you're thinking about security as you're building the system. You're not saying at the end, oh, and we now need to encrypt a few things, right? You need to have this if you really want to be PCI compliant today. I don't know how many people have to think about PCI compliance, but anytime you're dealing with any kind of personally identifiable information or some sort of credit card data or something like that. This is the kind of rules you have to follow in order to make sure that your system is not going to be compromised. OWASP, SOC 2 Type 2 in the US, anybody who wants to deal with us has to have a well-filled out CAIQ, which is where you're showing that you have taken the time to actually adopt security principles in advance. And we have Cassandra on this pass. It's given to us as infrastructure as a service. We know that this is always going to be available to us anytime our team that built the pass deploys into a market. But it's the one database I get. And for those who've used Cassandra, there are certain semantics to it which don't fit every use case. One of the things I did whenever I was at TypeSafe and Lightbend was work with a large consumer electronics company located in Cupertino. And actually they're very public about the fact that they have extremely large Cassandra footprints. Apple, right? Last I'd heard several years ago, they had 75,000 nodes, and that's not a single cluster, but multiple clusters, I'm sure. And the reality was they actually had two of them. It wasn't just one 75,000 node one. Cassandra does amazing things at scale, but it's also a dynamo store, and it's going to have much more eventual consistency semantics. And you can sit around and try and play with the various consistency levels, replication factors, and quorums that you're going to use. But at the end of the day, you're really trying to take the database away from what it does extremely well. And my use cases aren't always going to align with those kinds of semantics. So when we looked at Cassandra and said, well, okay, if a customer is coming in and we know that they're going to do an accrual event where they are buying a coffee and they're going to get stars from this coffee and be able to redeem them at some point, the accrual is something that I don't know when I'm actually going to receive. It's not an event that comes from our point of sale. It goes through a credit card processor, and that credit card processor could actually send it to me anytime within 24 hours. So when you see a rewards program and you don't see your stars or your mileage points or whatever right away, in a lot of cases it has nothing to do with the system design of the company that produced it. It has everything to do with whoever is actually doing the payment processing for them. However, a redemption event is something that has to be done fairly quickly. And when a redemption event occurs, there are semantics that mean that eventual consistency just doesn't work really well for us. Think about it in terms of the void of a transaction, right? Whenever that occurs and it's a redemption, a void of a redemption transaction, and then being able to buy another coffee with the stars that they had. Those are all things that don't loan themselves particularly well to an eventually consistent store. So Cassandra doesn't really solve all of the business problems that I have to deal with. And one of the things we started doing was saying, what would? Well, when we think about those sort of databases, we have to break this down to the most elemental, concepts and stuff like that. And I'm sure the majority of the people in the room have heard of the CAP theorem, right? The idea that you're making a choice between consistency and availability in the face of a network partition. And it really defined the way we thought about databases for the last 10 years. Because we knew that to increase the scale, we had to have more nodes. But the more we have more nodes, the less we can guarantee that we're going to have a consistent read. This is really the basis of how those CAP theorem-defined dynamo stores would work. You would write to a certain number of nodes. You wouldn't say all of them, because if you were saying that, then you're asking for a fully consistent store. But in doing so, you're limiting your availability. When we want availability and we want to have systems that are going to be resilient and staying up all the time, we have to take into consideration that we're going to have eventual consistency just because of physics, the nature of I'm going to write to several of the nodes, and I might read from one of them that has not yet been updated. So how do I deal with that? And then the question becomes, while that defined the way we thought of the last 10 years, are new theories starting to disprove the CAP theorem? And even more importantly, are we optimizing for the wrong case? So I'm going to talk a little bit about later on how maybe when we thought about AP, the idea of availability in the face of a partition, were we really optimizing in the wrong direction? So has anybody ever had a database that never went down? Anybody? No. So what does AP really mean? If we're sitting down and saying that we're going to have a database that has 9 nines of uptime, and this is like the classic Erlang, uptime theoretical guarantee. right? That you could have theoretically 9 nines of uptime. It's amazing to think about. What is that, Francesco? It's on the order of 3 seconds in a year. Fantastic. Who doesn't want that, right? But we don't get it. And if we don't have that, what is the point? What is the point of saying that we have an AP system? Now, Daniel Abadi, has anybody ever heard of this fellow? He is a researcher now at the University of Maryland. He was previously at Yale University in the United States. He said that we're not really thinking about this the right way, and instead he decided to frame the terms around something he called PACELC. And this is where he's saying that if there is a partition, well, then we can start making trade-offs around availability and consistency at that point alone. Otherwise, the real trade-off we're making is between latency and consistency. And we can have consistent semantics inside of our programs and inside the database, so long as we're accepting the fact that network partitions are rare. Now, I actually had the pleasure of meeting Daniel Abadi I think a year and a half ago, in China at this massive event held by Huawei, and it was incredible. It was like this, there was Ian Stoica from Databricks there. There were people talking about Flink. There was this great combination of the researchers and academia and enterprise. And Daniel was there talking about a distributed file system. And he was basing it on something called the Calvin paper that he had written, where he was talking about PACELC. And Daniel mentioned, network partitions are rare. And that set off bells in my head. Because how many people feel that network partitions are rare? Now think about them in terms of how many operations you're actually performing and how many are affected by a network partition. And this is where Daniel was going with it. He said we're optimizing toward this availability consideration when it's really a small percentage of our overall transactions that are affected by that. And because I didn't understand what he meant by rare, I actually argued with him, not like, bitterly or something like that, but it was one of those cases where I'm like, they're not rare. I worked at Juniper Networks for like a year and a half. They happen all the time. And he was saying, no, they're rare. And once I started understanding what he meant by rare, which was a good year later, I suddenly went, oh, that's a really big change in the way that I'm thinking about how I'm storing data. So I sent him an apology email and said, I'm really sorry about that, and he was very, very kind about it. He said that, Calvin is the sort of thing that people don't get it first, and then later on they really start to grasp. So if we talk about just data management taxonomy, so we get a feel for the sorts of things we care deeply about, I'm going to leverage a little bit of Kyle Kingsbury, the person who created the Jepson series, and the way he tends to think about this, because his definitions are quite good. First of all, we have to make sure that we understand the difference between consistency in ACID properties versus consistency in the CAP theorem. And when we talk about it in terms of the ACID properties, we're talking about the transition of a database in a transaction from one valid state to another. It has nothing to do with distribution across multiple nodes. It's merely the idea that consistency means that a transaction occurs and you go from one valid state to another. Whereas when we're talking about the CAP theorem, we are talking about consistency in terms of, am I getting the same data whenever I read from different nodes, right? Serializability. Can I have guaranteed write order? Now, there are no claims as to what that order might be. You can define that, or the database could define it, but either way, to have serializability, you have to have a guaranteed order of some kind. And linearizability. Are all nodes going to have that order? More importantly, if I have linearizable consistency, no matter where I read from, am I always going to get the same value in a distributed context? So these are all things that we wanted to make sure we had if we had to implement a system that had to have consistent semantics, but still have availability in case nodes or an availability zone or even a whole region went down. How are we going to deal with that? And then you get into the whole optimistic versus pessimistic concurrency, locking inside of databases. They all have very similar kinds of concerns around them. When you're talking about optimistic, you're talking very much about compare and swap. And that's great. It sounds fantastic until you get into a write-heavy context. If you're doing tremendous numbers of writes, those compare and swap type semantics are going to be more difficult because the value's changing all the time. One of the things we came across in Juniper Networks back in 2012 was we really wanted to use software transactional memory. It sounded incredible. Until we got to the point where we were thinking about a 20 million item double linked list that was changing thousands of times a second. Now, there's no determinism around how compare and swap starts to fall over, and no determinism, therefore, about how software transactional memory will fall over. At some point, you will, non-deterministically, begin to see the inability to commit a transaction. And that's one of the difficult things about it. And you see hardware transactional memory now trying to replace this. I see very smart people, such as Gilton A., as huge fans of where hardware transactional memory is going. And Margot had that tremendous talk this morning about how they want to be able to leverage those semantics inside of what she's doing. And hopefully, it will work. But I've also seen Intel pull it back once or twice, and disable those instructions inside of chips that they've released. So I'm not entirely sure that it's 100% ready. I don't know. I don't know anybody actually leveraging it. Is anybody leveraging hardware transactional memory yet? Is anybody leveraging software transactional memory? I mean, you might be in Haskell or Clojure or something like that, right? And so long as, like I said, you don't have overwhelming amounts of writes taking place, it can work great. Pessimistic, on the other hand, is the idea that I'm going to lock something, I'm going to do my operations, I'm going to commit, and then I'm going to unlock. And that sounds, great, but it comes at its own cost. However, you can, so long as in a distributed context you don't have nodes going down or the inability to reach them and then worry about how you're going to deal with the lock that it's holding. How are you going to compensate for that? And we've got, really great people working in that space and solving that problem for me so I don't have to. This is why I want databases. This is why I want Kafka. So the solutions that are out there that are worth considering, at least in this new space, are largely available across these cloud providers. I'm going to go through them sort of one by one and how we personally evaluated them and what we were thinking. Amazon Aurora. How many people have used Amazon Aurora so far? A couple. It's MySQL in the cloud, which is great, actually, to a certain degree. Because when you think about it, it means that you get the ability to almost plug and play your application directly into it. It's not a completely different way of interacting with the database than you were before. And the SLA around Aurora is actually pretty significant. 9 nines of uptime being guaranteed in a MySQL system. I'm not sure I could get 9 nines of uptime myself trying to run it. That's not easy to do. The compatibility with existing solutions, like I was saying. But the one thing about whenever you think about these kinds of systems based on a master and replica type of architecture is that you're still always bound to what the master is doing. And in that particular case, what if the size of the box that it's running on isn't big enough and you need to swap out for one that's bigger? Well, then you have to take the master down, and that does imply downtime to swap it out for the new one. And then you have quorums for reads and writes across availability zones, which is fantastic. It's multi-data center. Your performance limit is to the bound of the master's box that it's running on. And this is really giving you pessimistic locking, so you have throughput at the cost of latency. How much time are you going to wait for somebody to unlock what you're trying to also update? Vertical scalability, no sharding. That's difficult. What if your data set is larger than the master? What if you need to be able to scale across multiple nodes, and then you really can? So Aurora is actually something we are considering for our architecture, because if we're going to use Cassandra for the majority of the cases of all of our microservice architecture, they each have their own dedicated database space that they're using, but we can limit our points, the view of our points, to a MySQL in the cloud instance. It might work really well. The question is whether or not the business is willing to give up the idea that we're going to have downtime for maintenance whenever we have to switch from one master to another, and that there is a finite limit to the amount of records that we could store in it. Since it's only points, it may not be quite such a big deal. It's not all the data that we're trying to put in there. But we're still evaluating it from that perspective. Microsoft Cosmos. Anybody ever use that? It used to be DocumentDB, so it's not a database that's totally brand new. It is being marketed in a completely different way, however. And it's declarative consistency. This is the idea that you get to sort of choose the level of consistency you want to pay, but at a global scale. And this is where we are seeing people starting to let go of the idea that the CAP theorem was the Bible. You know, Eric Brewer himself, back in 2014, started making noise through InfoQ and other channels about how CAP was really not entirely a binary choice. And when he was talking about it, I thought he merely meant that whenever we were looking at Cassandra, that if we tuned our settings around, you know, the replicas and the quorums and the consistency level, that we were going to have a, you know, a tunable line between consistency and availability. But that wasn't it at all. It's really where he was going next. Azure does have ACID-style transactional applications to it. And like I said, it evolved from DocumentDB. If you like having that enriched kind of view of data that's based on a document of here's all the fields inside of it and also the value for it, it's very much like a Mongo store. And Mongo is an interesting case in and of itself because you look at how it recently passed the Jepsen series back in, I think, February. And this is a really big step for Mongo because replication in Mongo wasn't exactly well respected. Losing rights was something that people just kind of accepted as the cost of doing business. But if you were using Mongo as a cache to hold just data temporarily while you were doing operations, it could work pretty well in that context. That said, now that it's passed the Jepsen series, it is now reliably passed in what we would probably consider the most authoritative test suite in the industry for replication, at least publicly accepted. There may be others that are not like available for all of us to use. And that does not, however, take into account sharding, and it also does not take into account performance. So when you think about Jepsen, don't automatically associate those properties with those tests. The declarative consistency model is nice. You don't get uniqueness or foreign key constraints, which, you know, isn't atypical, I think, of document stores. You also don't get distributed transactions. How many people do distributed transactions now? All right, one. Do you do sagas, sir? Do you do the saga pattern or anything like that, or are you using like XA or something back in the day? Or oh, you're using Erlang. Okay, and are you doing Amnesia or okay? When it comes to distributed transactions, I mean, we all know that there are costs associated with them. And historically speaking, I wouldn't say that many platforms have had a lot of success with them. Erlang is a platform that is unique in those kinds of regards, but when you're talking about distributed transactions, ordinarily, this is the sort of thing where you have to implement a saga pattern. And by that I mean export with the transaction the way to roll it back to the store itself. Because what if it can't talk to the rest of the world? And it can't say, am I in consensus with the other place that had to be updated at the same time? I need to then pull it back. If you're looking for a really great talk about sagas, I recommend you check out Katie McCaffrey's talk. She formerly worked at Twitter, but she's just recently joined Microsoft Research in Seattle. I'm very excited to have her in our town again. So really excellent talk. I'm sure if you just look up Katie McCaffrey and sagas, you'll find it. Now we get into the interesting part where we start talking about the really crazy new stuff, and that's like Google Cloud Spanner. Anybody read the Spanner paper? A few people. Martin, I'm not surprised. Martin Kleppman from Confluent. So Spanner is the idea of global consistency as well, but with a completely different view than where Cosmos was trying to take it. And you have globally distributed consistent data. Eric Brewer, the writer of the CAP theorem, is not working directly on Spanner, but as he says, he's a big fan of it. In this particular case, it's only available on GCP, and obviously Aurora is only available on AWS. Microsoft Cosmos is only available on Azure. These are limitations for me. Like, I can't deploy to GCP right now. Our pass is over AWS. We're not going to be cloud portable. That is not a requirement or a concern of ours. But that does mean that I don't get access to Cosmos or Spanner. But I'd really like it. It would be so cool. One of the things about Spanner in particular, and unfortunately this part is proprietary, is the concept of true time, where using Google's wonderfully fast network, they can sit down and figure out order at the read node, at the leaf, how to order all the transactions that have been committed across all the nodes on a global basis. Now, I also don't have a use case where I personally have to worry about global consistency. I do care about it within a region. Because of things such as, global data protection regulations, GDPR, I cannot be deploying a view of United States data in the EU. Japan's data has to be separate from, other countries. China, I don't even know what kind of access I'm going to have for that sort of thing. So for me in particular, this isn't a concern. At the same time, having within a region, within the United States, within Canada, within Japan, within EU, within UK, global consistency in a distributed context would be fabulous, because then I don't have to think about that and the race conditions that might result inside of my application. Now, mind you, when we talk about these sort of things and also ordering, one of the tricky things about this is it makes no guarantees about, hey, the order of when the transactions arrived. It can only disambiguate based upon what came into it. Now, when it comes to Spanner, the tricky thing is you have to use their way of talking to it. And they do have a new SQL kind of syntax, but like CQL, it's not a one-to-one match to, the ANSI SQL that people might be familiar with. That said, how many people got to work with the database that said they were ANSI compliant on SQL? Anybody? 100%. Not everybody really is. At some point, you're dealing with some sort of, dialect. It uses pessimistic locking, which it gets away with, again, because they've got a very fast network behind it that the majority of us don't get access to. Wouldn't that be great? 5 nines of availability with strong consistency. And by strong, I'm saying that whenever I read, I am guaranteed to get the value that I expected, no matter what node I wrote to. That's fantastic. And Spanner and Cosmos are also offering the same basic SLAs around throughput and latency and consistency, which is really, really amazing. They are bringing us in by offering levels of service that we might not be able to even achieve on our own. Now, the tricky thing about those sorts of solutions, as I alluded to earlier, is whether or not they're going to be secure. And then there's also the cost of how local they are to my application. I'm going to have transit time trying to connect to their databases wherever they're located. Are they going to be really close to my app or not? And I really don't have guarantees about that, nor do I necessarily want to frame my application around those sorts of concerns. I want that kind of portability in that regard. I don't want to be sitting around trying to optimize around the locality of the database. So you start looking at things that you might be able to install on your PaaS yourself. And you come to things such as CockroachDB. Has anybody played with CockroachDB yet? This is, okay, one person. This is basically saying that we can have an open source spanner, which, sounds really exciting to me. I want a database that maybe I can control in my own context and have all the control of the data and not worry about the security. But because CockroachDB can't use true time, it's kind of left in a lurch. And Chris Mecklejohn and I were talking about this in Seattle just a couple months ago. And he had this really great explanation that I'm not even going to try and say verbatim, but the basis of the time mechanism inside of CockroachDB is NTP. And there's a certain amount of drift that occurs across time, across every one of the boxes that this database is going to be installed on. And that means that the database, in order to figure out how to manage that consistent view and order, has to also figure out how to deal with drift. And that means you have to pay a latency cost, at least at current time. I'm not sure how much further CockroachDB has gotten, at least things that they publicly published around how much they're progressing in this regard. But I think the general rule of thumb is that it's roughly on the order of 200 milliseconds. And those are expensive costs to pay for a database read or a database update. So it did pass the Jepsen test. Again, this is the closest thing we have to an industry standard around the consistency of a distributed database. That's fantastic. But because of the cost of the latency, this is something we didn't want to consider. Now we get to FaunaDB. And now I want to talk about how this relates back to PACELC and Daniel Abadi. Fauna is based on the Calvin paper. And the Calvin paper is basically saying that I'm going to write all my transactions into a distributed log. And just for reference, think of it in terms of if it was Kafka. Right? We're all used to the idea of putting something into Kafka. And when it goes into the log, at that point, I'm going to pay the cost to figure out what came in what order, and then I'm going to push it out to all the read nodes. So by the time it reaches a read node, it is already guaranteed to be ordered and consistent, assuming none of those nodes go down. Now, if the nodes do go down, it's falling into the PACELC realm, where it's saying, now we will pay the cost of what we do in availability versus consistency. But they're in essence saying that the nodes that go away are not part of the ring anymore, and you're not going to be making requests from them. It is transactional with single-phase commit across thousands of records and indices, and then with an optimistic locking approach instead of pessimistic, which is where you see Spanner going. I can't say that we've deployed this into production, but we have been doing a pretty heavyweight POC. And we have written on order of 100 million transactions to this database so far and not seen a single consistency issue, despite taking down nodes, which is pretty impressive. It's serialized and it uses RAF to manage the order of the updates. It's linearly consistent. It's got hierarchical row-level authorization for tenants, which is actually a really cool thing for us, because if you start looking at Starbucks' business model, you go into a Starbucks and you actually don't know who owns it. We sold all of our stores in Germany last year. In the UK, it's largely franchises, which means you don't have large organizations running it, but maybe one group of people owns a couple stores. And a lot of that has to do with the fact that in a lot of respects, we're also a real estate company. We have to manage real estate. And in the UK, it's not a viable proposition for us as far as the business model goes. In Korea, we're a joint venture. In China, we were a joint venture. Now they're all company-owned. In the US, we have various licensees, such as stores like Target and various supermarkets and stuff like that. And all of this layers into a complexity of a business model. It makes it really difficult to say, are we not going to have to manage tenancy inside of our database, such that we say, this is Target's data, this is AmRest's data for Germany. We need to be able to think about tenancy in a completely different way. It supports multiple indices, which is great for reads. You don't have to come up with, does anybody here do like CQRS? The idea of command query responsibility segregation, where you're saying, I'm going to have a writable store. I'm going to transition that data into some sort of readable views. And those readable views end up being a non-relational, real quick access kind of thing. Based on some key, can I get a whole bunch of values? And in the case of Fauna, I really don't have to do that because I can use multiple indices for my queries. It supports temporality, which is also good for audit and rollback. David Nolan was just talking about this as far as Datomic goes, being able to say that I want to get the data as it stood as of this time. And it can do that. And it has, supports graphs. And I think part of this has to do with the Fauna team, the team that built this. They really came out of Twitter. And their underlying philosophy for what they were trying to achieve was, we built a whole bunch of specialized stores for, Twitter. And you saw a couple of them, like FaunaDB, which is a graph database, right? And they said, well, what if we could just build the perfect one? Now, that automatically starts setting off alarm bells in my head, because there should be no such thing as a database that does everything great. Personally, I don't care too much about graphs. I'm not trying to figure out the social network of the coffee drinkers, at least yet. It's not a requirement anybody's actually put on me yet. But that said, it does have these capabilities, and if you needed to leverage them, then you could do it within a single store. But let's think about some of the things that are kind of a negative. And one is that FaunaDB is a closed source database. And to be honest with you, this is really the trend in open source. It's an unfortunate reality that there just isn't much of a business model around selling free stuff. And I know this from the time that I spent 4.5 years at TypeSafe Lightbend. You end up spending a tremendous amount of time coming up with products that a lot of customers can't leverage. So, for example, FaunaDB does have a SaaS-based solution that they're hosting, allowing me to theoretically just use their database. But then I've got to get into all those questions around security and how they're going to manage my data, and make sure that they're following PCI DSS, and make sure that they understand SOC 2 Type 2. How many startups, whenever they're like 20 people, actually have that capability or knowledge? Now, to a certain degree, they do. But it's still not a risk, and all of the evaluation we have to go through means that we would only be deploying this in our own footprint. Transactions are limited to a single function. And to get into that into the semantics of how you're doing your queries and your updates, it's with their own query language. Now, very much like what we saw with Datomic, you can adapt to a query language because typically they have very similar semantics. But it does have a training overhead for your team, and whenever you're talking about a large enterprise like Starbucks, these are the sorts of things that managers are going to sit down and say, cost, 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 cost. It's a new product. It's growing in maturity. There's one publicly disclosed user of it right now, and that's NVIDIA. I do know of a really large financial institution that is evaluating it much as we are. That's also in the United States. And because of this lack of existing users, of course, that means that the case studies for managers to feel comfortable about making a choice like this are thin. And of course, you're beholden to whether or not NVIDIA is willing to talk to you about what it's like to actually operationalize this thing. It's not verified by Jepsen, but in this case, Evan Weaver, the CEO, made the conscious choice not to do that as a personal friend of Kyle Kingsbury. In that particular case, he was saying, yeah, we agree that Jepsen is a pretty good series of tests, but we want to go further and test it deeper. And there aren't many people who I would trust to say that they understand what further and deeper means than Kyle Kingsbury's tests and Jepsen, but Evan is one of them. And we did look over the tests and run the tests ourselves, and we were generally impressed. But one of the bigger problems here, whenever you're talking about adopting a new technology like this, is what happens if it doesn't exist anymore? Apple acquired FoundationDB, I think, in 2014 or something like that, and it was an open source database, and all of a sudden, boom, done. No access to it. What are you going to do? No, if you installed it, you don't get maintenance updates anymore or anything like that unless somebody picks it up and starts running with it. You see what happened at Basho. I was a huge React fan. I used that at large cable companies in the US, and it worked extremely well for us in making read views and stuff. Unfortunately, with Basho gone, now you see, I think, is it LMAX or Betfair? One of the two of them picked it up as a database that they're now providing at least financial support around as the community reorganizes to support it. And then you see RethinkDB, which pretty much just kind of disappeared because, again, business model of free software, it's very difficult. But getting into that business model around free software, wither Cassandra. DataStax, is obviously a big vendor for us, and we're extremely impressed by Cassandra. I mean, who wouldn't be? It does amazing things when used in the correct context. But they're more and more moving away from the open source project because of how hard it is to sell something that is free. And at this point, their contributions to the open source Apache project they've really dwindled to a trickle, if anything at all. Some of this has to do with the business model question. Other parts of it have to do with the politics of being part of the Apache Foundation. And whenever you control the technology, you have to be able to give up that control to be as part of that foundation. And those dynamics aren't always positive for the companies who are trying to make money and support this as a long-term endeavor. So Cassandra is actually starting now to talk about their own closed source solutions that move away from the Dynamo paper. And while I was supposed to have a meeting with them to discuss their roadmap before this, unfortunately I didn't. We are going to meet probably in the next 2 weeks, either the 17th or the 20th. And after that, I'll have a much better feel for what it is they're going to be doing in order to support different semantics around Cassandra. But until then, I'm sorry, this slide is unfortunately blank. Nonetheless, open source is a really tricky place to be as far as selling things. And what you see VCs doing, they're investing in these companies and telling them they have to be product companies. You can have consulting and services around them, but they have to be limited to 30% of your overall revenue. And 70% has to be generated from product. And the reason for that has to do with valuations, which is the number one thing a VC will care about. Am I going to have a valuation of a services company, which is on the order of 1x to 1.5x? Or am I going to have a valuation of a product-based company, which they see as high as 10x? So obviously, there's a big incentive for them to have you pushed toward a non-services model. And that's actually restrictive, if you ask me, toward the adoption of so many of these great technologies, because there's less people out there to help you do it. Every single one of the companies I worked with said, I just want somebody around who can make sure we're doing the right thing. And unfortunately, if you are being guided by a VC, you're not allowed to provide that service. And instead, you've got to build a whole ecosystem of other providers who can do that for you. So this is a tight space that you see so many of these companies in. So that's really my talk. Does anybody have any questions?
I think there's definitely going to be some questions. We've got 5 minutes for questions. Anyone up?
Yeah.
Just to clear up that React comment that you made, it's actually Bet365 that purchased Basher's IP.
Okay.
And the intention is to, as well as support the community, we're building a whole team to take the development forward, along with several other organizations, including the NHS.
Which, this is actually a really great thing for open source, where you see a company almost adopt an open source project and say, we're going to be the financial and community supporters for this, right? It doesn't mean that you as a user are going to get the features or fixes that you want, because let's face it, Betfair being the sponsor, they get to make the call, and that's fine. I mean, you're still getting access to an amazing tool. That said, let's look at, say, Netty. Netty right now is largely kind of controlled by Apple, because the primary person who runs that project, Norman Marr, works for Apple. So Apple kind of gets first dig at what they want inside there. Now, mind you, we all benefit from the things that Apple puts in there, right? The things that Norman is doing to support Apple go into the open source project, and that's to our benefit. Just, there are caveats. So, but thank you to Betfair for doing that.
It's Bet365.
I'm sorry?
It's Bet365.
Bet365. I'm so sorry. I'm totally mentioning the wrong company. It's Bet365 who's doing it. My apologies.
We got another at the back.
Hi. With respect to Cassandra, have you been looking into ScalaDB as an alternative?
I'm sorry, I can't.
ScalaDB?
ScyllaDB.
Scylla, I don't know how to pronounce it.
So ScyllaDB is supposed to be the idea of Cassandra, but faster, right? Which does affect the latency toward eventual consistency, right? Which is great, except it's still a Dynamo-based database, right? And it still has the semantics of eventual consistency at the, at trying to give you availability at the expense of consistency to some degree. And if there was a deterministic way to say that I was guaranteed to have an update within so much time, then fantastic. But nobody's willing to make those guarantees, even at the increased performance of Scylla. Now, mind you, if I'm writing an analytics platform or something like that, and I need to have quicker access, faster consistency, or at least gossiping and stuff like that, Scylla is definitely a platform to consider. But again, it's not the problem we're solving. And in this particular case for Starbucks, Cassandra was something that had been selected even before I showed up, and it was the database we get, period. So, yeah.
All right, who's next? I knew it's Chris.
Uh-oh, it's Chris.
I just had a question about, so I mean, the Fauna story is nice, right? Calvin is nice, but the question I have is, if you build assuming this geoscale, single, strongly consistent view, whatever, strict serializability, what happens when you reach the max throughput? Like, where do you go from there?
Yeah.
What's the operational story? Like, because then you probably have to decompose things into services, right? And so maybe why not start from that way and build up? I mean, what are your thoughts on that?
Okay, so you're asking first if, what do we do whenever Fauna reaches its maximum theoretical throughput and stuff like that? And again, because we're limiting it to a single storage of one kind of value, the points, which are associated to some membership ID. In our testing, we have not run into that limit. And our testing has been significantly greater than our actual throughput, and it hasn't been a concern yet. If we ran into it, what would we do? I don't know. I mean, we'd have to start thinking about how to reorganize our actual system in order to take into account the limits of the database. But I don't want to do that kind of complexity now. The scale, like I said, is on a relative scale not that great. I mean, 91 million financial transactions a week is nothing to sneeze at in one market. And it is a company that has a $30 billion revenue every year and a market cap of almost 90 billion. But at the same time, it's not high-frequency trading, right? So I'm lucky that way.
I think we've got about 60 seconds left for one more quick question. Anyone else? Go one.
Why is it I know all these people?
Hi, Jamie.
Hi, Chris.
So if I'm remembering the Google Spanner paper correctly, I think with TrueTime you have the same kind of problem that CockroachDB has, where you've got like a minimum bound on your latency.
Yeah.
Have we got that right?
It's true, but because
What kind of
their-
numbers are we talking about there? What is that bound for, say, Google Cloud Spanner?
What is the actual number?
Yeah.
I don't remember, but it's significantly lower, mainly because of their speed of their network. So, and also think about in terms of how they're doing this. They're doing this at the leaves, right? The disambiguation is happening at the read nodes themselves with pessimistic locking. And the only reason they can get away with that is because of their network. But, you know, I don't remember the actual number in the paper myself.
Okay. But it's a reasonable number. You could actually...
Certainly much less than the 200 milliseconds that we were thinking of in terms of, you know, Cockroach.
Okay.
I guess that's it for the questions. If you've got any further, you can ask the host directly at the end. Thank you very much, Jeremy.
Thank you.